This week's lab is called Spectroscopy and Beer's Law. First and foremost, there's no beer, there will be no beer. Please don't tell your parents that you did a lab with beer. It's a person's name, Beer's Law. Okay, I like my job, I like to keep it. So, this instrument is called a spectrometer, or it's also called a Spec20 for short. And what it does is it measures the light that is absorbed by a solution. So what we're going to do is make some solutions and see how much light they absorb. There's a light bulb over here. There's a place to place your sample inside that chamber. And then there is a detector which tells you how much light is absorbed. That's the way the instrument works. Our goal today is to make solutions of cobalt nitrate hexahydrate, which is this compound, and then use known solutions to calculate molarity of the unknown solutions. I have here A and B and C. I am trying to discover the molarity of those three solutions. Okay, don't need those till later. What we need to start with is one partner will begin to calibrate the instrument. That means set it up so that it knows what to look at from 0 to 100. And the other partner will start to make solutions. First, to calibrate the instrument, you need to set the wavelength, this is the wavelength, using the top knob here to 510 nanometers. The knobs are pretty sensitive, so you want to be very patient and move it a little bit at a time until you reach the right number. Okay, then the next thing is, we are in, you can see the red dot here next to the word transmittance. We are in transmittance mode. We would like the number here to read to be 0 exactly when the chamber is empty. So, the left front knob is the 0 knob. We want to move it, you see it's negative, we want to move it up. Again, very sensitive. Move it up a little bit at a time until that number reads exactly 0. You can see the negative sign flashing, that is okay. Then we want to make it read 100 when the cuvette has only deionized water. So, by the way, this is called a cuvette. It looks like a test tube. It has a special name for this instrument. There it is. What you do is every time you put this into the sample chamber, you wipe your fingerprints with a Kim wipe. This is a Kim wipe. You really only need 1 or 2 of these through the whole lab. Please don't use the entire box. So you wipe off your fingerprints. You can hold it at the top. You put this into the instrument. And what we want is for this number now to read 100% of the light being transmitted. The 100 knob is the right front knob. So you slowly move that, and again it's very sensitive, until you get to exactly 100. And no. There it is. Stay. Good, Spec20. Okay, then we could take that out and close the chamber. Now, just make sure that the number goes back to 0, which it is. That instrument is ready to go. The last thing you do is you switch it to absorbance mode by pressing this button, mode. When you do, it will start flashing 1999. That is because all the light is being sent to the detector and it is way off scale. That is normal, that is fine. When you put your first sample in, it will give you an actual number. The number for absorbance is a number between 0 and 1. It is unitless. So 0 means no light is absorbed by your solution. 1 would mean all the light is absorbed by your solution. So that's ready. Meanwhile, your partner has been making solutions over here. So the first thing you do is you grab your 50 milliliter beaker and go to the balance where you find the compound. And you're going to weigh about approximately 1 gram of the compound. That looks like this. Right there, there's 1 gram of the compound. It is a red solid. Again, it doesn't have to be 1.00. This is 1.05. So any number around that area would be fine. Record that number. Now we need to transfer that solid into the volumetric flask. This is a 25 milliliter volumetric flask. You saw these last year. I don't know if you used them yourself, but I know you were taught how to do this. You can see also, I don't know if you can see it, but when you get into the lab, there's a line which gives you exactly 25 milliliters if your meniscus is touching that line. So what we do there is you're going to dissolve your solid, because you can't pour a solid. You can dissolve the solid in your deionized water. So you're going to add about 10 milliliters of deionized water to this solution, and then you're simply going to transfer it. Now, the cap of this is a pretty tight fit, so you want to take your thumb and push the cap off. Once the solution is dissolved, you can pour it into the volumetric flask. If there's any red solution still left in here, you want to add some more water and make sure all of the red solution gets into the volumetric flask. Then you're going to fill the volumetric flask up to the line with deionized water, and then you can cap it. The cap, again, is a very tight fit. I like to go kind of from one side over to the other. It snaps on tightly. And then shake it up, shake it up, shake it up, shake it up. Okay. That solution is the most concentrated solution you'll use all day. That is called the stock solution. Again, I know you learned that last year, the stock solution. Okay. Then the rest of the lab is making solutions from that stock solution, making dilutions, and measuring their absorbance values. Okay, so what you do, and here's my stock solution that I already made, the magic of video. So we're going to put different combinations of stock solution and water into our cuvette. I'm going to just demonstrate once so you know what we're doing. So what you need for the first solution is you need 1 milliliter of stock solution, that's this one, and you need 4 milliliters of water. The deionized water and the stock solution you're going to measure using volumetric pipettes. Again, I know you saw these last year. I don't know if you can see this very well. It has a 4, probably not, but there's a 4 on this, and there's a line that you fill it up to. There's also a very convenient thing called a pipetter that we attach onto the top. Okay, so I have the pipetter. When you put this on, gently put it on. Don't push it further than it feels like it will go, and then you're done. Okay, so I'm going to put 4 milliliters of water into my cuvette. You put the tip of the pipette under the water level, and now this wheel causes me, this wheel, I can roll up until my amount of water reaches the appropriate line right here. You want the meniscus to be exactly touching that line. You can move it up or down until you're at the right height, and then you're going to transfer it directly into the cuvette and let it all drain into the cuvette. Okay, it's as simple as that. You're going to do the same thing with your stock solution, but you're going to transfer 1 milliliter of the stock solution. And when you put that all together, what you get is a solution that looks like this, where you can see it's lighter in color than my first solution. I diluted it, and now that is my first solution. I would like to measure the absorbance. What do we do now before we put this in the instrument? Don't forget, you wipe it with your Kim wipe, no fingerprints. Fingerprints will block some of the light, and we want an accurate reading. Now, when you put this into your calibrated instrument, it gives us a number for absorbance. So we're saying 0.146, that is our absorbance value. Now, what happens there is that is saying that 14.5 or 6% of the light is being absorbed. That's the number we write. There's no units, it's just 0.145. Record that number. Now, when you're finished with that solution, you simply dump that down the drain, and then you go back to your water and stock, and you make a second solution. You make 2 milliliters of stock with 3 milliliters of deionized water. You can see it will always be 5 milliliters total, which is what you need to measure it inside the instrument. You go through until you are completely with 5 milliliters of stock. So you're going to have 5 solutions you make in the cuvette and 5 absorbance values you record. That is all known solutions. You know the molarity of this because you put in the number of grams, you can calculate the molarity of that solution, and then you can calculate every time you dilute. There's a handy-dandy formula, again from last year, M1V1 equals M2V2. So you're able to calculate all those solutions' molarities, and you have their absorbance values. So we're going to make a graph of absorbance versus concentration, and that'll tell us everything we need to know about this compound, cobalt nitrate. The last thing you do, once you've emptied your cuvette, is we need to measure the unknown solution molarity. So here's solution A. All you do not dilute this solution. All you do is you put in approximately 5 milliliters. Wow, that comes out fast. Okay. You put in 5-ish milliliters of solution A. That's a little too much. And now again, I want to measure this solution. I grab my Kim wipe. I wipe my fingerprints off. And then I put it into my instrument, which I won't do because you can do that yourself, and everyone will have a similar value for this. Put it in, record your value. You do the same thing with unknowns B and C, and that is all the data you need. So you're going to use the known solutions to calculate the molarity of the unknown solutions. That, again, is the goal of the lab. Don't forget, we will have a quiz, as we usually do, and I will see you on Wednesday.